New images from the James Webb Space Telescope, JWST, have revealed, for the first time, starlight from two massive galaxies hosting actively growing black holes, quasars, seen less than a billion years after the Big Bang. The black holes have masses close to a billion times that of the Sun, and the host galaxy masses are almost 100 times larger, a ratio similar to what is found in the more recent universe. A powerful combination of the wide-field survey of the Subaru telescope and the JWST has paved a new path to study the distant universe, reports a recent study in Nature. Observations of giant black holes have attracted the attention of astronomers in recent years. The Event Horizon Telescope, EHT, has started to image the shadow of black holes at the galaxy centers. The 2020 Nobel Prize in Physics was awarded to stellar motion observations at the heart of the Milky Way. While the existence of such giant black holes has become solid, no one knows their origin. Astronomers have reported that there exist billion solar mass black holes within the first billion years of the universe. How could these black holes grow to be so large when the universe was so young? Even more puzzling, observations in the local universe show a clear relation between the mass of supermassive black holes and the much larger galaxies in which they reside. The galaxies and the black holes have completely different sizes, so which came first, the black holes or the galaxies? This is a chicken or egg problem on a cosmic scale. An international team of researchers led by Mahfuza Anu, a Kavli Astrophysics Fellow at the Kavli Institute for Astronomy and Astrophysics, KIA, in Peking University, Xiuhing Ding, a research fellow at the Kavli Institute for the Physics and Mathematics of the Universe, Kavli IPMU, and John Silverman, a professor at Kavli IPMU, have started to answer this question with the James Webb Space Telescope, JWST, a 6.5-meter space telescope developed by an international collaboration among NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, and launched in December 2021. Quasars are luminous, while their host galaxies are faint, which has made it challenging for researchers to detect the dim light of the galaxy in the glare of the quasar, especially at great distances. Finding the host galaxies of quasars at redshift 6 is like trying to spot fireflies in a breathtaking fireworks show while wearing foggy glasses. The host galaxies are incredibly faint, and image resolution has been very limited, even with the Hubble Space Telescope. The team observed two quasars with the JWST, HSC J22360032, and HSC J22550251, at redshift 6.40 and 6.34 when the universe was approximately 860 million years old. These two quasars were originally discovered by a wide-field survey of the 8.2M Subaru telescope, with which the research team has identified more than 160 quasars up to date. The relatively low luminosities of these quasars made them prime targets for measurement of the host galaxy properties, and the successful detection of the hosts represents the earliest epoch to date at which starlight has been detected in a quasar. The images of the two quasars were taken at infrared wavelengths of 3.56 and 1.50 micron with JWST's NIRCam instrument, and the host galaxies became apparent after carefully modeling and subtracting glare from the accreting black holes. The stellar signature of the host galaxy was also seen in a spectrum taken by JWST's NIR spec for J22360032, further supporting the detection of the host galaxy. I have been deeply involved in the Subaru survey of high redshift quasars since my PhD years at National Astronomical Observatory of Japan. I am extremely proud of the successful starlight detection from the HSC quasars that we found with Subaru, says Mahfuza Anu. From the observations, the team found that the ratio of the black hole mass to host galaxy mass is similar to those seen in the more recent universe. The results suggest that the relationship between black holes and their hosts was already in place within the first billion years after the Big Bang. The team will continue this study with a larger sample of distant quasars, aiming at further constraining the coevolutionary growth history of black holes and their parent galaxies over cosmic time.